Thanks for coming to the Dash behavioral model work group. And so what I'm showing are the notes from last time where we talked about the inbound pipeline model creation, went over that. Now that one has gone through quite a few reviews and that's been approved and merged in the Dash community call stemming from this call. So we've done that, and we actually have a couple more PRs that have been coming in, a couple more HLDs from riffs, so I can put those into the chat here while we're talking. And then I know that we were looking at the P4 DPDK, and I hadn't heard that there'd been updates, Macy or anyone, but it's been a couple of weeks, so I guess I'll check in.
Yeah,
How's that one going?
no news is slightly bad news.
Okay, okay. No news, bad news. Okay.
I mean, I think it's basically just, people. I mean, it is open source. Anybody can work on the bugs, of course.
Yeah.
But yeah,
Yep.
of course, the people who've written the code tend to be the ones who enhance it most often and fix issues. So,
Yeah,
and
yeah. And we did
they've been.
have somebody yesterday who is trying to submit a fix. His name's Meyappan for one of the issues that we had listed. But I think Marian had something he wanted to talk about. So, Marian, did you want to share or do you want me to present?
Oh, I will share. I just
Okay,
wanted
I'll
to,
stop.
yeah, to show the draft that I have. I still haven't added the ReadMe file that will describe all that, but I will do it live now, and then for everyone to view offline, there will be a ReadMe file. So this is the pull request 453 refactoring tunnels. It doesn't add any new functionality, but I'm trying to arrange things a little bit so that they will simplify pipeline itself to make everything in a fixed place. So the problem that we had before, we had this kind of header layout where we had what we would call inner fields and inner headers and outer headers and different options for the tunnels between them. And it was getting a little bit hard to work with because when you don't really know at any point in the pipeline where your customer headers are, because if you do the decap, this thing moves up. That's what we did before. So that outer becomes your customer, and after you do a new encapsulation, you push things down, and then customer headers move back here and stuff like that. And also it didn't support multiple layers of encapsulation. Like, for example, if you want to add more tunnels, how would you do that? So what I tried to do is to arrange them into fixed positions. So we always have now the customer headers that are parsed into this place. And we have our underlay 0, underlay 1. I added as well, so we can do 2 layers of tunnels, and it is extendable for more with with also a tracking possibility for tracking how much tunnels we already added. So for example, if packet comes like this, outer, which is U0 and customer headers, and you do decap, you just invalidate this and decrease the tunnel pointer. If you, for example, want to add 2 tunnels, you do it once, you increase tunnel pointer once. When you will call tunnel encap once again, you will now add this thing. This stays in the same place, and this throughout the pipeline, the customer headers also stay in the same place. So it had to it involved fixing a few files that kind of upgraded with that, because in some places they were outer where now they needs to be the customer and so on. So I did updates throughout those files. I also added these shortcuts, kind of like what we had before. Let me find it. So this different targets for the end caps, but at the end you have essentially this tunnel end cap macro, which will call the corresponding either the push VXLAN tunnel or push NVGRE tunnel, and I added two definitions for example, if the tunnel pointer is 0, then you add a push VXLAN tunnel underlay 0. If the tunnel pointer is, seems like a bug. Should be 1. If the tunnel pointer is 1, this should be this part should be used, or push VXLAN tunnel you want. For now, we don't have the case for that, but I am working for a use case to push 2 tunnels, so I will test these things out as well. Same thing with NVGRE, and we can kind of, with this thing, we can extend it to more tunnels if needed. So at the end, in the outbound, essentially looks pretty much the same. You just have this tunnel end cap, which substitutes VXLAN or NVGRE because you pass the dash encapsulation over here. So you pass the same information, you do the tunnel end cap, but you don't really need to keep track of which tunnel is that. It's done by the tunnel pointer. And also there is a tunnel decap along with the tunnel end cap. However, tunnel decap has one assumption. So tunnel decap assumes that we only have one layer of encapsulation. In case we in the beginning of the pipeline, in case we need to strip more than one tunnel, we'll have to recirculate the packet. But that's just the kind of the behavioral model implementation. Doesn't mean that real implementation needs to recirculate the packet. It's just how it will be described, that essentially you'll need to kind of reparse it again, because if you had 2 layers of encapsulation, then customer headers weren't parsed at all, because parser starts always at U0. So then you will need to redo it once again if you will need to if you have an indication that you actually had 2 layers of encapsulation, and you need to do double decap, for example.
So I feel like I read about underlay 0 and underlay 1 back in the document provided by Riff a week ago. Is this the implementation of what you guys wrote together in that?
I just tried to align the names to that. So there are 2 parts. One is the naming convention, underlay 0, underlay 1. And second part is to have throughout the pipeline to have customer headers at the fixed place.
Because we didn't know how we were going to handle customer headers in multiple layers of encapsulation. But
sometimes you need to match on the outer. Sometimes maybe you need to still do some kinds of transformation, but now they are in there. And the next table that is matching on outer is now actually matching on the underlay, not the customer. So to eliminate the need to actually keep track of the pipeline, you can look at one table and understand on which headers it's actually operating.
Looks beautiful to me.
Marian, do we need, like, this is probably older implementation, but if you check the headers, like dash headers .p4, I have one question on the structure. So here you see the underlay 1 also has a UDP TCP, underlay 0 also has UDP TCP, and customer definitely will have UDP and TCP. So do we need this, like the
well,
the
we
ones
need, yeah, you're right. We need UDP because UDP goes with VXLAN, but we probably will never encounter TCP. Yeah, I can safely remove TCP.
Yeah. That makes sense. That makes sense. Cool.
We won't encounter TCP. Okay.
Mm-hmm.
Okay.
Yeah, otherwise we have to like pass the TCP, push the TCP over. So yeah, it's one less thing to worry about.
Yeah, it's better to not have it than other errors may be caught.
I even think I'm even thinking about like removing the UDP by using maybe look ahead. Just say, hey, this is the port we are looking at. Like for the VXLAN, then we like only goes to there. I mean, if it is not that port, then we will like not putting the data here, like the parser directly pass the UDP packet, like UDP header into the customer UDP header, instead of like we afterwards we doing the push. So yeah.
Sort of, but I'm not sure if that would be easier to understand. Plus, you need to emit the header anyway, right? To do the proper deparsing. So in the parser, you'd still need to emit UDP. You cannot just skip it to have the proper packet structure.
Oh yeah. I mean, if it is VXLAN, then UDP is still here because part of the incap. If it is not a VXLAN, then you can directly goes to the custom UDP, so we don't have to like fix fix the structure anymore.
Not sure I understand that.
Let's say we have a VXLAN encapsulated packet with UDP payload, or yeah. So the parser passes into the first decap, and then from there we see, okay, this is a yeah, maybe it's not a good example. Because it's all. Oh yeah, sorry. Let's say there is a UDP. There is UDP packet without encap. Say the like the for example, like the if the what is that, the Alibaba would like to use an Ethernet gateway, so the packet will send to here will not have the encap. And then it's a UDP packet. Yeah, it's UDP packet. Then the parser processes it. So it gets Ethernet gets a IPv4 header, then it goes to UDP. So in that case, the underlay 0 UDP will be, or the underlay 1 UDP, I should say, will actually be used for parsing UDP. But then from there we see, oh, the port is not VXLAN port. Then we skipped, moving further, because that's basically the end of the parsing. But in this case, we could say, let's look ahead from when after we parse IP header, we look ahead and to check the port of the UDP. So if the port of UDP it is the VXLAN port, then we continue parsing. If it's not, we move to parse the customer UDP instead. Then we have one less header to worry about, because the UDP information is always in the customer side. Not sure if that makes sense or not.
So there won't be any encapsulation in that case. You simply have the customer header.
Right. That's a net gateway case. There is no encapsulation at all. or the load balancer case, you see there is no encapsulation at all.
Mm-hmm. Yeah, okay, I see. Interesting example. So we get the customer header as the outermost one. Okay, I'll need to think about that.
Right. Yeah. I proposed some ideas in the packet flow doc. So I'm not sure if that makes sense. You can check it out.
Yeah, I'll check it out. Mm-hmm.
Yeah. And I think all the other things are mostly minor. But yeah, I think this one maybe we can optimize a little bit. Cool. Yeah, that's all the things I have.
Thanks, Ref. Vincent, do you have anything to say? You usually do. Mr. Legrand. Okay, guess not. Well, looks good, Marian. Thanks. Did you want to put, is Riff on as a reviewer?
It's a draft
Yeah,
because I
Oh, it's
haven't
draft.
added
Yeah.
ReadMe
yes.
yet.
Yeah, never
But I
mind.
will add
Yes, I'm seeing this
reviewers.
draft. So I didn't leave any comment. It's like, yeah,
Yeah.
Marian's working on that.
Okay.
Mm.
Well, I'm taking notes too.
Yeah,
Thanks,
I need to
Marian.
fix up the PDK target and the ReadMe and probably take this customer outer header case into account as well, how that is supposed to work. And then, yeah, then I can add reviewers.
Okay, cool. Were there other ones you wanted to cover, Marian?
No.
Okay. Can we look at the potential fix for 415 that Meyappan submitted and run it by your guys' eyes? He did submit, was it here, 463 to cover 415. If we remember, 415 was this, I think it was a one-liner fix theoretically.
Yeah, it's just a typecasting fix.
Yeah, and so we were like, okay, if you could make a PR. And so this is the PR. And sorry if I did that very quickly, but this is the file. They changed line 64 here and 342 here.
So my aide probably review it offline because I haven't had a chance to
Okay. It was
catch
just
up
this
with.
morning, I think. Yeah.
Yeah.
Make sure.
I verified in the CI log that the warning's gone now for that compile and passes all the CI tests. But it would be great to have you take a look at it,
Oh yeah.
Marian.
Yeah, and you are a reviewer here, and then
Camille
was
okayed
good
it and I
with
okayed
Okay.
it, but
Okay.
we want the originator to take a look at his code.
Yeah. Okay. So in this one, I can say, yeah, maybe.
Yeah, it's great to get some help from new community
Yeah.
members.
Wow. That was really nice. Hopefully it'll fix it. CPR. Maybe people are learning BMV2 and P4, Marian. That would be a good thing.
This is actually straightforward C++.
Oh, is it? Okay. All right.
Which is probably harder than P4.
Oh, okay. And then I think that was everything. Marian, Amit and Meyappan were also going to look at this one, but I think they were working on the other one first. And this is where it's, we get 5 objects when we should get 1 or
Yes, I
something like
remember that one.
Yeah. So I think they're going to give that one a swing too.
Cool. Yeah, I will review the one that's ready. It seems to be easy to approve, but I'll just want to make sure.
Thank you so much. Yeah,
we were not missing anything.
Okay. And then did anyone, Riff, did you have anything you wanted to cover today?
Not really. Not sure.
Okay.
Yeah, any other questions about like flow review simulation? Because I see you put it over there.
Yeah, I did. I put it right here.
Yeah.
So I'll probably read through this again. It takes me usually half of my Friday to go through this. So if
sounds great.
I'll pop it in the chat window too, maybe. Yeah. So Chris or Mircha, do you guys have anything you want to cover?
Not myself.
No. Okay. Let me see.
Oh, I just want to make one community comment. And Andy and I have been talking with Jamal Salim, who's been pushing the P4 PC backend.
Mhm.
And he's actually reached out to us about what kind of special requirements there are in Dash that he can take into account for the P4 TC implementation.
Mhm.
And so we're having an ongoing conversation, but he's trying to push that upstream into the Linux kernel. And for people who haven't been following this conversation thread, Jamal's been for quite some time working for Intel, and he's been putting improvements into the Linux kernel that can support P4 natively in the kernel. And you can push programs into it from user land. And it can be a very compelling performant backend. So we've had conversations trying to make sure that he can handle the Dash use case. So that's an ongoing conversation. We'll see where it leads. But he's very open to finding really compelling software, I should say, use cases that benefit from a software backend for P4. So at the sake, think of it as a parallel track to the P4 DPDK. It's like yet another software backend.
Yeah. What's Jamal's last name?
Salim, Salim.
Okay. Well, that's interesting. I think Riff brought up that P4 test gen with me yesterday when we were talking, and we had talked
Yeah.
about that, and then we had talked about P4 TC
Oh yeah,
after
from
that.
from Fabian Ruffy, yeah.
Mhm.
Right. I had a meeting with Rafi talking about like P4 test gen. I actually run it already. Like he generated 10 test cases for me. It looks pretty promising though. Have a few comments. I probably will reach out to him again and send the feedbacks.
Yeah, some of my colleagues took a look at it and were pretty impressed.
Yeah, it's fairly fast. I would say it's much faster than before. Yeah.
Then Bud, I noticed you just joined, and so you missed out. We had a really good conversation around this PR right here. So added a lot of stuff. Not actually, it's not. Actually, was it this PR? Yeah, this one here. Added a lot of stuff into this PR for like customer headers, multiple encapsulation, blah blah blah. So it's interesting. And then Andy, did you have anything before we go?
Oh,
sorry, had to hit the mute button.
That's okay.
No additions today. I'll probably send you an email. I had a topic maybe for better discussion at the Wednesday meeting about the possibility. So I'd asked some time ago about getting access to real production style ACL configurations.
Mhm.
And I've been looking into it a bit more and was wondering if there might be a way to, if not get access to those, maybe access to some kind of anonymized statistics about production style ACL configurations that might be used by testers.
Okay.
But I can get more into that next Wednesday.
Yeah. Hey, Sushant. Sushant, are you able to talk at all? I'm not sure if you're
Yeah,
on still.
I'm
Yeah.
kind of in out because I'm incident manager also, so getting
Yeah,
pulled into other calls.
Yeah. So what Andy was asking for is, do we have a way to? Well, Andy, why don't you just ask?
So the kinds of ACL configurations I understand from previous asking. So some of them are written by Microsoft and sort of, and some of them are written by Microsoft's customers, and those are definitely under NDA and not to be shared anywhere outside. And even Microsoft's, I mean, in general, any access control list used for security in your network, publishing those is kind of like publishing the perimeter defense plans for your fortress of solitude. So there's no good reason to do that, and only bad reasons to do that. But in the past, at least, researchers who've looked at these kind of configuration problems and ways of solving packet classification have sometimes gained access to them and then like produced anonymized statistics about things like how many rules on average, how many groups in a tag, how many prefixes in a tag kind of thing, what the prefix length distributions are, what the typical L4 ports are. They usually ranges, usually exact match, usually wildcard, those kind of statistical analyses of actual production rules, and then publish the statistics in a way that you can then auto-generate like random ACL configurations that are similar in their statistical distributions to the actual production ones.
Okay.
So anyway, I wanted to talk more in detail about that when I have some slides ready to describe it, and we'll pass those along to the team probably by next Wednesday.
So you are going to share some of these statistics, or is your ask like if we have anything like that?
The
So
second one, I think.
the ask would be, is there, well, so first, I don't currently have a program that I could just say, here, run this on some, private ACL configurations and share them.
Yeah.
This is more of a, would Microsoft or others be open to the idea of, if I collaborated with somebody and said, hey, I'll write you a program that will create these anonymized statistics about production ACL rules. You get to look at those output files and make sure that they really are anonymous and don't reveal private information. Would you then be willing to share those statistics with people developing algorithms for the ACL configuration?
So you will, so then you will run it from somewhere, like you will create how are you going to do it? Are you going to run like a virtual machine in Azure and try to run some traffic and see, what's going through, what's getting dropped, like whatever your some mechanism? Is that how you're going to do it?
The proposal would be, that I have in mind, is not to capture any traffic. It's only to look at a ACL configuration, a production-worthy ACL configuration, calculate some statistics about it, and write that to an output file that could then be shared publicly.
And what use will that be, like getting such data?
So in the past, when I've asked about this, I think Gerald DeGrasse's response has been, well, we just want people implementing Dash products to implement things that handle arbitrary ACL configurations in the worst case.
Yeah.
And if you, I'm coming up with some slides to summarize this, but if you look at actual worst case ACL configurations, there are no good algorithms that scale well. Like they either are horrible on packet, classification time, or they're horrible on amount of memory required, or they require lots of TCAM, which is horrible in power usage. So worst case, there really aren't known good solutions. And so most of the algorithms that do this kind of thing today rely upon typical configurations, things that people actually configure, and that they aren't worst case. They often have properties that are much better than the worst case kind of configurations. And so knowing some statistical properties of what typical configurations look like without revealing private information. So for example, there's an open source tool published 20 years ago that, not for Dash configurations, could analyze private configurations, publish some statistics files, and then they would have a program that would read the statistics file and say, hey, generate me an ACL with 1,000 rules that looks statistically like this file statistics. And then researchers could use that to develop and test ACL packet classification algorithms and say how well they worked against those artificially generated rules.
Okay, so this is mostly to test the perf for scale of your implementation by running it through some real usage data, like on Azure hosts, what are the real ACLs being used, like, or a close representation of that. And that will help you see how your solution is going to perform once it's released out in the wild.
So it wouldn't run on real Azure hosts. It would run on researchers' machines, but they would be able to generate ACL configurations that they know are statistically similar to production configurations.
But the motivation is to get close to like real world data, so that your perf like test is giving you accurate representation of how it's going to perform once it's going to be used by users.
And the main difficulty with that is, for very good reasons, for security reasons and NDA reasons, you and others don't want to give away actual production configurations, but maybe statistical summaries of them might be acceptable to publish.
Yeah, okay. Yeah, do you have like, so what I just explained makes sense to you, right? My understanding is correct?
Yeah, and
Cool.
he'll have a proposal like once he
Yeah.
works on it. We don't have to solve it today, but if
Okay.
he comes up with a proposal, we could run it by you and Rishabh.
Yeah. Yeah. I think that will be good. Why don't you write it down? And I mean, if it helps us come up with a solution that's good for the users, we'll be open to it. But we'll just need to make sure we are not, revealing something that goes out in the open source and can, cause some problems. So
Perfectly agreed. Yeah. I mean, one way that this might work is over time, I develop a program that you can run on production configs, look at by hand a few of the example output files to see, yes, these are just summary statistics with no way of reproducing the original configurations before you decide whether or not you want to publish those statistical analyses.
I think maybe without giving you the actual IPs and ports that we use in the ACLs, maybe we can give you some, like how many groups, layers, and rules we kind of do on typical NIC.
So my proposal is that the program that I would develop or somebody that I know would develop would automatically produce those statistics for you without you having to do anything.
Yeah.
Once that program.
Hi, John.
Yeah.
Hi, John. So, essentially, I guess essentially in a like Dash Sonic HLD, the scaling requirements capture the view about like how many echoes per NSG, how many NSGs per ENI, how many prefixes per ENI, that sort of things. But from what you're saying, I feels like you are looking at more detailed statistics besides those things. So.
I am.
Yeah. So I'm wondering, like, if you can, like, just summarize some categories, and then we can work it out.
Yep, that's
definitely my plan, and I don't have the slides to share with you for that yet.
Sure.
But
no worries. Yeah.
And John, when you say
Andy,
you were,
yeah. Sorry, or is it? Do you go by John too, or is it just Andy?
My middle name, I go by my middle name Andy, but my Intel
Okay.
name, yeah. Sorry, but go ahead. I'll answer you.
Okay. Sorry,
Andy. So Andy, so I would also like to know a little bit more about how you're going to auto-generate this. What's your plan for that? So if you can include that also in your document, that will be great.
Sure. So what I don't have code for you right now, but I can point you at a 18-year-old open source project that I can point at code that doesn't do it for group-based. I call the problem that Dash solves sort of a group-based access control list because you can have tags that have many prefixes.
Yeah, exactly.
There's the older style classification model that doesn't have tags, that just has individual prefixes in each rule. And there's already an existing open source tool that, given the appropriate statistics file, can pseudo-randomly generate, arbitrarily large number of rules with statistically similar properties that I can point you at that. And my goal would be to generalize that for the group-based, tag-based configurations.
Okay. Yeah, I think we should definitely keep in mind the requirements that we have on how many ACLs per group and how many groups, things like that. But sure, let's go through your proposal and see if we can, get some more reliable numbers in terms of performance that we will see if we can get some real world numbers for you.
I mean, one possible use of this, besides for, like people doing research on new algorithms, would be they could be used by, Keysight's team to generate pseudorandom large configurations and do performance testing on actual proposed Dash products that you're considering buying.
Sure.
Great, and so
they might help your vendors, improve their products based upon real world data or statistically similar to real world configs.
I'm on a call with a bunch of researchers here, but I noticed you're off mute. Did you have anything before I close out?
No, I was just showing up to get the checkbox. Sorry, I was late.
Okay, yeah, and I think I mentioned this PR is pretty cool. I think you would like this one, 453, where it addressed these pieces here about.
All right, I'll go check it out.
If you have time. If you don't, that's okay. So anyway, great. Then I'm gonna stop the recording unless there's anything else.
So I have like 2 small PRs.
Oh, sure.
Really small PRs.
Go for it.
Not like the BMV2 related, but just
Okay.
asking for review. Yeah.
Okay. Which ones are they?
Oh, that's okay. I sent it to the chat, but it's like
the 2 in the chat.
Yeah, not behavioral model related. Is more like fixing, spell checks.
Oh, okay. Okay.
Yeah. Okay.
Chris is still
Cool.
on the phone. Yeah.
Thanks.
Chris, can you help with those? Chris is on mute. I'm sure he'll
Yeah.
check the thing. Okay, great.
Sounds good.
I'm gonna stop the recording, and this is always such an intense call.